Yes. Coming to the next question, show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1 where q is some integer. So here in this particular question they have mentioned every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1. This is what we need to prove. Right. Now, whatever the numbers we have, for example, in the general, natural numbers, we have two types of numbers. One is even numbers, one is odd numbers. Right. So here, let a is an integer. Let a is an integer. As we have 2q plus 1, I am taking b is equals to 2. I am taking b is equals to 2. Now, according to Euclid division algorithm, I can write in the form of a is equals to 2q plus r. A is equals to 2q plus r. Right. So here, whenever we are dividing with number 2, it means what? The remainder is always which is greater than or equal to 0 and less than the number divisor. Right. That already we have learned in the Euclid division algorithm. Now, the remainder is less than or greater than or equal to 0 and less than the number 2. So, greater than or equal to 0 or less than 2 is nothing but what, sir? So, what are the possibilities we have? We have a possibility 0 and 1. So, here these are the two possibilities we have, okay, in case of 2q plus r. Now, if I take 0 as the remainder, now what will be the values? A is equals to 2q plus 0 is my number. Now, if remainder is 1, 2q plus 1. 2q plus 1 is also the one of the case. Right. When the remainder is 0, okay, this number will only be the multiple of 2. This number is only be the multiple of 2. Multiple of 2. Right. Now, coming to this number is multiple of 2. This will be even, and even plus number 1 is equals to obviously odd. Obviously odd, right? If I take number 2 and if I add 1, what happens? 2 plus 1 is equals to 3. Yes or no? If I take 4 plus 1 is equals to 5. So, 4 is an even number. If I add 1, obviously the result will be odd. So, here the number which is in the form of 2q is what? Even, and the number which is in the form of 2q plus 1 is odd. Clear? Right. So, that every positive even integer is in the form of 2q and odd integer is in the form of 2q plus 1. Now, coming to the next question. The next question is, show that every positive, okay, show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer, right? Where q is some integer. Now, I am taking my integer is a. Now, I am taking my integer is 8. Now, what will be the divisor? Already, okay, they have given that 4 will be the divisor, right? 4 will be the divisor. Now, I am taking b is equals to 4. According to Euclid division algorithm, what we can write? We can write like a is equals to 4q, okay, plus r. A is equals to 4q plus r. So, according to what? According to Euclid division algorithm. Now, we know that r can be a what? R can be what? R can be what? 0, 1, 2, 3. As we know that r is greater than or equal to 0 and less than b. So, according to Euclid division algorithm, whatever the possible we have, what are the possible reminders? The possible reminders are 0, 1, 2, 3. Now, when you write in each case, so case 1, what is the, what is the case 1, sir? Case 1 is equals to what? Case 1 is equals to 4q plus 0 and case 2 is equals to what? Case 2 is equals to 4q plus 1 and case 3 is equals to what? 4q plus 2 and case 4 is equals to what? Case 4 is equals to 4q plus 3. 4q plus 3. Now, when you observe this question, now 4q, the multiple of 4 will always be a even. When you add even value to the number 0, obviously the value will be even. Now, here 4q is an even number. When you add even to the number 1, obviously that will be odd. Now, 4q plus 2. Okay, so here 4q is even. Even plus even obviously will be even. Now, even plus odd will be odd. Even plus odd will be odd. Now, what we need to prove? So, here 4q plus 0 and 4q plus 2, both are even numbers, right? Even numbers. Now, what are the odd numbers? The odd numbers are 4q plus 1 and 4q plus 3. 4q plus 1 and 4q plus 3 are odd integers, Okay, so this is what we have to prove, hence proved. Right, now coming to the next question. The next question is, right, a sweet seller has 420 kaju burfis and 130 badam burfis. Okay, she wants to tag them in such a way that each stock has a same number, and they take up the least area of a tray. What is the number of that can be placed in each stock for this purpose? So they are taking less area in the sense what, sir? That they are taking less number of boxes. Yes or no? They are taking less number of boxes in the sense what we need to find? We need to find maximum number of seats in each box. Okay, maximum number of same kind of sweets in each box. Okay, same kind of sweets in the sense what are the types of sweets we have? Kaju burfis and badam burfis. These two are the type of sweets what we have. Right, now what we need to do? We need to divide, we need to find the HCF of 420 and 130. Now, what are the numbers? 420 and 130. In this, obviously 420 is the greatest number. So, we need to divide 420 with the number 130. Now, 130 into 3 is equals to 130 into 4 is equals to 130 into 4 is equals to 52. So 520, which is not possible. Now take 130 into 3, that is nothing but 390. Now 133 is 390. So by subtracting here I am getting 30. Now divide 130 with the number 30. Okay, so 34 is 120. By subtracting here I am getting 10. Again divide 30 with number 10. So 10 3 is 30, here I am getting remainder as 0, so that HCF will be what? HCF will be 10. Now, according to Euclid division algorithm, how we can write? So, 420 can be expressed as what? 420 can be expressed as 130 into 3 plus 30. Yes or no? 130 into 3 plus 30. After that, 130 can be expressed as what? 30 into 4 plus 10. So 34 is 120, 120 plus 10 is equals to 130. Now again divide 30 with number 10. So when you divide with 10, 10 3 is 30. So the remainder will be 0. Whenever we get 0 as a remainder, in that case, whatever the divisor will be there, that divisor will be act as a HCF. Now HCF of what? HCF of 420 and 130 is how much? 10. Now, what they are asking? They are asking that, what is the number that can be placed in each stack of this purpose? So, how many pieces they will place in each box? They will place 10 sweets in each box. Clear? 10 sweets in each box. So, if they are asking about how many boxes are required to pack, two kind of sweets, then what we need to do? Now, again we need to divide. So this is not given in the textbook, sir. This is additional case. Now 420, we need to divide 420 with number of sweets in each box. So the 10 ones are 10 42s are, it means 42 boxes are required to pack kaju burfis, and 130 divided by 10, that is nothing but 13. So that is nothing but 13 boxes are required to pack badam burfis. The total number of boxes will be 42 plus 13 is equals to 55. The total number of boxes are 55. Clear? Now coming to the next question, sir. Exercise 1. Euclid division algorithm to find HCF of 135 and 225. So that's this is about the exercise problem. So use Euclid division algorithm to find HCF of 225 and 135. So we know that 225 is greatest number than the number 135. It means what? We need to divide number 225 with the number 135. So 225 divided by 135. Now 135 ones are 135. By subtracting, here I am getting 0, and 12 plus 3 is equals to 9, and this will be 0. So now divide 135 with the number 90. So 90 ones are 90. By subtracting, I am getting 45. Now divide 90 with number 45. 45 twos are 90. By subtracting, here I am getting 0. Now as I got 0, now 45 will be what? 45 is what? HCF is what? 45. HCF is 45. Now when you write the numbers in a what? In a Euclid division algorithm. So how we can write? So 225 can be written as 135 plus, okay, 135 into 1 plus 0, sorry. So 135, okay, 225 is equals to 135 into 1 plus 90, and 135 can be written as 90 into 1 plus 45, and 90 can be written as 45 into 2 plus 0. So that, okay, HCF of 135 and 225 is how much? 45 is 45. Clear? Now coming to the next question. Right, HCF of 196 and 38,220. 38,220. Now coming to the next question, 38,220 and 196. We need to find the HCF of these two numbers, right? Now divide 38,220 with the number 196. 196 ones are 196 by subtracting 186. After this dropping 2, so 1862. Now 196 nines are 196 into 9 will get 9 6 are 54, 4 5, 9 9s are 81 plus 5 is equals to 86, 6 8. Now 9 1s are 9 plus 8 is equals to 7, 1764. 196 nines are 1764 by subtracting, here we will get 98. Now by dropping the 0, 980. Now 196 fives are 980 by subtracting 0. So here as I got the remainder 0, now the divisor will be the HCF as we know. Now what we can write? We can write like, okay, so 38,220 can be expressed in the form of what? 196 into 195 plus 0. So as I got the remainder 0, now 196 will be what? 196 will be the HCF of 38,220 and 196, right? So the HCF of these two numbers will be 196. Clear? Now coming to the next question. The next question is, find the HCF of 867 and 255. Now 867 we need to divide with the number 255. Now 255 times 4, so will be not come. Okay, 255 into 3 multiply with 3. So 3 55s is nothing but 3 5s are 15, 5 1, 3 5s are 15, 16. Okay, 3 2s are 6 1, 7. 765, 225, 3 is 765. By subtracting, what we are getting? 7 minus 5 is equals to 2, 6 minus 6 is equals to 0, 8 minus 7 is equals to 1. We need to divide 255 with the number 102. Now 102 times 2 is equals to 204. By subtracting, here I am getting 51. Now divide 102 with number 51. 51 2's 102. The answer will be 0. As I got the remainder 0, now 51 will be the HCF. So according to Euclid division algorithm, how we can write? We can write like 867 can be written as 255 into 3, 255 into 3 plus 102. As a reminder, 102 here, 102. Now 255 can be written as what? 255 can be written as 102 into 2 plus 51. 102 into 2 plus 51. As I got the remainder 51. Now divide 102 with number 51. So 51 times 2 is plus 0. So that as I got the remainder as 0, so 51 will be the HCF. So HCF of 867 and 255 will be 51. Clear? So this is what will be our final answer.